So we're going to discuss something called the point-slope form of a linear function, and it's really exactly like it sounds. We're looking at the slope of a line as well as a point on the line. Now this point, and I'm going to write it in green over here, this point is not the y-intercept point. Okay, because before we were using the y-intercept as a point, so it was whatever the y-intercept was and then x at 0. But this is any point that the line passes through that is not the y-intercept. The general point slope formula is y minus y1 equals m multiplied by x minus x1. And a couple things to note about this formula, because it's not read exactly like your slope y-intercept formula is. So the y1 and the x1, that's the point that we're talking about. That is not the y-intercept, right? Not y-intercept, but it is a point that the line passes through. And then, of course, over here, your m is the slope of the line, and that's going to be constant throughout the entire line. The regular x and the regular y over here, those are like the final point on the line that we found our slope from. So remember that to find the slope, you need 2 points. So the y1 and x1 refer to the point that is often already given in the question. And then your y and your x without the subscripts of 1 are going to be the reference point that you would find your slope from. So one example of a question that involves the point slope form is as follows. A line with a slope of -3. So what I'm going to do is I'm just going to underline that and write a little m over it. Passes through the point 1 and 3 on a graph. Express this in point slope form. So we're not really solving for anything here. I just want to take this information and communicate it using the point slope formula. So if this is a point on the graph that is not the y-intercept, then that would be the x1 and that's the y1. So if my point slope formula is y minus y1 equals the slope multiplied by the x minus x1, then we can just write y minus 3 is equal to minus 3 and then x minus 1. And here are the variables that we took from the question over here. And so this is a pretty straightforward, simplistic question. Just plugging it into the formula. Another typical question we could get would be like the one over here, where we say a line with a slope of 2 passes through a point 2 and 9. Write in point slope form, then convert to slope y-intercept form. Okay, and for those that are, again, unfamiliar with what that is, that's the signature y equals mx plus b format. So remember, if this is a point that is not the y-intercept, then that is going to be the x1, the 2, and then the 9 is going to be the y1. And this is going to be the m value. So the first thing we're going to do, like it asks, they want us to write it in point slope form. So we're going to go y minus 1 equals m x minus x1. And then that'll be y minus 9 equals 2 for the slope multiplied by x minus 2. Okay, so what we can do is, so this is the first part of the question. Now for the second part, to convert it, if this is my equation, y minus 9 equals 2x minus 2, then what I can do is I can do distributive property over here in order to open up the brackets. And when I do that, I would have y minus 9 is equal to 2x, 2 times x is 2x, minus 4 from 2 times -2. Now what I can do is I can gather these like terms by moving the 9 over here. And in order to do that, I'm going to add 9 on both sides. That would remove it from here. So then I'm left with y equals 2x minus 4 plus 9. And then I can simplify these terms here. Y is equal to 2x and then plus 5. And if we think about slope y-intercept form, here's the slope, right, your m value. And then the b, or the y-intercept, would be over here. And so it is in y is equal to mx plus b. Now, what if we're given just a graph and we're not actually explicitly given the slope or the points? Well, what we would do is, like we're going to do over here, we can use the graph to get the slope and get the point, or have some sort of reference point, and then convert it into y-interslope or point slope form. So it says use the following graph and the point. So the point that it's talking about is over here. So here's the point. So what I'm going to do right now is I'm going to label that point. I could see that that point is at 5 and about 4. And that's going to be x1 and y1, because it's not the y-intercept. And then what we're going to do is we're going to get the slope of this line. So using the rise over run, I can see that the rise over here, from the green point to the purple point, remember we read from left to right, the rise is 3 and the run is 2. So our slope is going to be 3 over 2. So now I have this slope over here and I have the point. So using that, we can convert it to the point slope form as follows. And that'll be y minus, we said y1 was going to be 4. The slope is 3 over 2. And then it'll be x minus the x1 value of 5. And this is the point slope form from the graph. So the last, most tedious, and most difficult types of questions that you can get when it comes to the point slope formula would be something like this. So a line has a slope of 1 over 3 and passes through the point 3 and 4. What is the x coordinate of another point with a y value of 5? So like we wrote in previous questions, the point that the line passes through, that is going to be x1 and that's going to be y1. This is our m value, and that would be our y. And so we're going to write the point slope formula, and then we're going to isolate for this x coordinate. Okay, so I have my point slope formula here, and we're going to sub in everything that is given to us in the question. So under the y value, we have 5, and then for the y prime or y1, we have 4. The slope is 1 over 3. The x, or the final x coordinate of the other point, is unknown. And then the x1 is 3 over here. Then when we solve both sides of the equation, we end up with 1 from 5 minus 4. And then 1 over 3, using distributive property, we get 1 over 3x. And then 1 over 3 multiplied by negative 3 gives us negative 1. And then what we're going to do from here is isolate for x. And we can do this in the following manner. So we can bring the 1 over here. And that gives us 1 plus 1. This is all using inverse operations. So we added 1 because this was subtracted by 1. So we have 2 is equal to 1 over 3x. And then you can approach this part really any way you like. Some people would divide both sides directly by 1 over 3. This would leave us with 6 is equal to x. The other way you could have solved this part algebraically would have been, if I go 2 is equal to 1 over 3x, I can cross multiply the 3 over here. That would give me 2 times 3 is equal to 1x, which 1 is redundant to write. We always assume a value of 1 beside a variable. And so then that would still give us 6 is equal to x. Either way is fine as long as your solution is correct.